any notes in the what? In the comment section?
I mean,
Yeah.
you don't directly point out the name.
Ah, okay, okay.
Because my name is not in the system. Yeah, we understand now. I'm the one who's teaching, but then the problem in the system is Dr. Jenny, who's supposed to teach, but then she's sick.
Ah, okay,
So
understood.
don't directly say what like Dr. Jenny is not responsible on teaching because she's sick and until the end of semester. Don't say that way lah. Okay, you should understand lah because she's still not stable yet.
Ah, okay, understood, doctor.
Yeah,
Okay.
yeah. Because we're afraid of this kind of comment. After if sometimes what we afraid is all of you student you know what you want to say, but then the problem, the way of saying is not really proper. Including later industrial training, also you will have this problem. I mean, when you come to industry, yeah, there are a lot of problems around us, but then you have to know how to pass the message, but then not shooting on the people. Sometimes later you will during industrial training you will train on this. Later you will know on this. Okay, so the same thing on for this course. For this course, yeah, I'm the one who's teaching, but then please don't directly shoot lah. Okay, directly shoot. You can just comment on probably the content is too heavy, or the facilities. Yeah, this thing you can comment. Okay, yeah, I mean I in fact the whole university are complaining already because the facility, the aircon not functioning well for the whole semester, and this is I think this is not only the first time lah. Okay, yeah, you can comment on the facility and so on lah. Okay, but then try to okay, try to comment in the other way lah. Okay, so test 2 already mentioned. Okay, this one already done. Okay, next one is group assignment. Okay, group assignment, I can give you the instruction earlier. Okay, I can give you the instruction earlier, but probably tonight. Okay, tonight. But then you can start to write out some part of the report first, just like what I already done for the lab subject last semester. I give you some time to do a study first, but then you don't do any analysis yet because the data are still with our speaker there. I mean, the speaker that I invited, Izwan, okay, from the GPS. Yeah, he will later he will provide the data, but then at the moment you can read I can let you guys read the instruction first, so you can think on how to plan the report, because you are supposed to only given 2 weeks time to finish, but then I give you earlier lah. Now is week 9, so you have 5 weeks to prepare lah. At least you 5 weeks to prepare, and then until week 12 later, when Encik Izwan give his speech, then you just continue it. Okay, this is for group assignment chapter 8. Okay, but basically you started your individual assignment. Basically, individual assignment and group assignment are linked to each other. So you have to do some literature searching for individual assignment first, then followed by this group assignment. Okay, so this is for group assignment. Okay, now the most important thing is your study week and your final exam. Okay, I think I cancel week 14 class because of probably you don't have probably you think you don't have study week because of informal exam. Okay, I can share some latest information about this tool. This semester, all of you have 5 subjects, right? 5 subjects, including hydrology. You have 5 subjects which have final exam, but 4 of them are still run informal. That means you still have to go to DKP to have the final exam, except hydrology. Okay, so hydrology will be informal, but then it originally was held in study week, but because Dr. Janice is still not around, and then study week I'm not around as well. Okay, I mean Dr. Janice is still not around, and during study week I'm also not around because I took my leave early already. I mean, before Dr. Jenny passed the subject to me, I already took my leave earlier. So study week, basically I'm not around. So I already requested your hydrology paper will still be run in informal, but then during first week of exam later. This one will be your final exam for hydrology will be on 9 July. Okay, 9 July. Okay. Yeah, 9 July. Yeah, 9 July, Friday. It's a Thursday. Okay. Okay, I let you know guys already. This one 9 July. Okay. The informal, that means it will run in. I mean, we will help it in the lab. I mean, the Makmau Lukisan there, okay, the lab that we always have our test there. Okay, it will be held there. But bear in mind, our faculty, the air conditioner is still not running well. So you get ready all your fan or anything like cooling item. Okay, during your final this. Okay, only hydrology it will be informal, but the other subject will be still held formally. Okay. Okay, any question?
Sorry, doctor, but so what? Only hydrology will be informal, so the others will. So which means we will still have the study break.
Yes, that means study week you are free now. You have your study week.
Okay,
The good news is you have your study week. Okay, but then the bad news, okay, I can tell you guys there's a bad news. Hydrology is on 9 but then on 10 there's another paper. That's the only bad news I got it. Okay, that means you have two subjects sticking together with there's one subject will be held right after hydrology the next day. Okay. Yeah, that's the only bad news I got. Okay, but I'm not going to tell you which subject lah because the exam timetable is still not officially announced yet. Okay, this is the prior information I got it, and then this informal exam is the one that I requested the date. So I let you know earlier lah. Okay, so just take note lah. Night the morning session. Okay. Okay, any question? No one? Okay. Okay, so by the way, what am I sharing currently? Is it the announcement slide? Okay. Okay. Now next one. Okay. So we shall continue. Okay. I believe all of you already go through chapter 6. Okay. Chapter 6 is I can say it's very short chapter, even though it's a lot of technical term in the chapter 6, but then chapter 6 is actually still very surface. Okay, what I can say is very surface. Before we start our today's class, okay, I recall back what we have covered throughout the course. Okay, so from what we learned in the hydrological cycle. So basically the whole hydrological cycle represent the whole course of the hydrology. So we have chapter 2, we have learned about precipitation. Chapter 3, we have evaporation, and then we have evapotranspiration. Chapter 4, we have infiltration. Chapter 5, we have groundwater. Okay, and then last week, Monday, okay. Chapter 6, you have started a bit on the surface runoff. Okay, but this surface runoff is really a challenging chapter. A challenging component, if I can say, because okay, surface runoff, we have 3 chapters here. First, we need to know, okay, so in your chapter 6, basically you already learn how to estimate the runoff quantity through that means you learn how to calculate the natural flow. And then also there's one method that you learn, how to estimate the flow, which is the SES curve number, SESCN method, okay? So this is what you already learned in rainfall runoff. Basically, it's from the rainfall data, how you estimate the runoff. Okay, runoff basically we can measure, but then we can also estimate. So this is from the rainfall data, how we're going to estimate the runoff. This is what you already learned in chapter 6. Okay, for today and next week classes, we will go into chapter 7, which is on the analysis of hydrograph. Okay, basically this chapter, we try to understand on the runoff behavior over the time. Okay, just like what you learn in chapter 2, rainfall part. Like rainfall, you know how we represent, how we present the rainfall data, like through hydrograph or the time series graph or the map. Okay, this is how we present rainfall. But in runoff or the discharge or the stream flow, we will learn on how we will use hydrograph to present the result. Okay, and then so chapter 7, this chapter is a bit lengthy. In fact, chapter 7 and chapter 8, both chapters are very lengthy. So chapter 7, basically, I will cover it next week as well. Next week we will do more on the calculation. And then we will have a short test. I tell you first, next week we have a short test. I want to test on you to make sure you know how to handle the data for chapter 7 first, because chapter 7 itself will be one question in the final exam, 25 mark, okay? So we will, today, next week, Monday and Wednesday, we will focusing on chapter 7 only. Okay, then after your semester break and after week 11, the holiday, Keamatan Festival Day and Hari Gawai, week 12, we will go into chapter 8, and that time, Encik Izwan will brief on the flood. Okay, because why I invite Encik Izwan? Because Encik Izwan is the GPS officer in Sabah. He will brief us on the flood situation in Sabah. Okay, I because I'm not Sabahan, so that's why I can't simply explain on the flood on Sabah, because I can tell you the flood in Kuala Lumpur or Semenanjung, the Peninsular Malaysia, but then I can't tell you I'm not the expert in Sabah, so that's why I invited Encik Izwan to present this. Okay, he will teach as well on this flood control a bit, and then later there's also some calculation behind that one. I will take over as well. I will teach later after his class, then I will teach as well. Okay, so this is the overall flow of the last 3 chapters. Okay, so chapter 7 we will divide it into 2 parts. Okay, so for today, part 1 will cover 7 subchapters. Okay, basically are all theories, mostly are theories. So that's why I conducted today cluster. Okay, because next Monday we will do calculation more. Okay, and please, if you want to bring laptop, you can bring your laptop, but please make sure you have to charge your laptop. Okay, charge out your laptop, because most of the example here have a lot of data. Probably you need Excel to do. To be faster lah. Okay, the present, so that you can follow up lah. Okay, because sometimes I might go very fast also. Okay, so we will start on the first 7 subtopic here. So hydrograph. Okay, so hydrograph is the graph showing the variation of stream discharge with time at a specific location in the river. Okay, means that if there's a river here, let's say we have let's say we have a river, and we have rainfall at this point. Okay, rainfall is precipitation, and from here you already learn on the SCSCM, whereby we learn once we have the input of the rainfall, and then we try to predict the outflow, which is the Q. Okay, that means we estimate the runoff based on the rainfall data at a point. Okay, but this is only for a point, or probably for a day. Okay, but when we come to many days or many years, then we have to present in terms of hydrograph. Okay, it's a time series graph. Okay, whereby the variation of stream discharge or the runoff. Okay, with time at a specific location in the river. That means from at a single point here, how is the changes of the runoff throughout let's say 30 years or 50 years, okay? Throughout 30 years, 50 years, how is the pattern of the stream flow, okay? So hydrograph here, the x-axis is still the time, y-axis is the discharge or the runoff, okay? Which, that means the unit is meter cube per second. Okay, so, and this hydrograph is important for us to analyze the flood and then watershed response. And then sometimes we also want to design hydraulic structure. For example, what we already learned in your, I believe you already learned in your hydraulic last time, okay? The hydraulic, you learn on the wheel. That means what, rectangular wheel or the trapezoid, the V-notch wheel, okay? Okay, we have learned all this wheel. Basically, all this structure designed on the river. So that's why once we know the stream flow discharge at a point for a river, then only we know the maximum point of the river, then we only know how to design the wheel or the channel, what we already learned in hydraulic, okay? And then it's also important for us to flood forecasting. Okay, so this figure shows a typical runoff hydrograph. Okay, so hydrograph usually we in the real situation will not be in this shape lah. I mean not in bell curve lah. But then but in our example, most of the example will be in the bell curve shape. Okay, so bell curve. In this graph, we have a few components that you need to know. Okay, so please take note. There are more technical terms that you need to memorize. Okay, first thing is the rising line. Okay, rising line, which is the representing the increase in discharge due to the rainfall asset entering the stream. Okay, that means once the rainfall entering the river, so the discharge will increase. So the increasing part here, we call it as rising line. Okay, then once it reach the peak here, the peak discharge here, this part we call it as the crest segment. And then once the water start to reduce, okay, the flow is reduced when the rainfall is stopped already lah. Okay, when the rainfall is stopped, so the water will be, the discharge will be reducing. So once it's reducing, this is we call it as the falling line or the recession line, okay? And then in a river, because what we learn in the hydrological cycle, there might be some groundwater as well in the stream. So here we call it as the base flow, okay? But then if we exclude the base flow from the total hydrograph, okay, that means from this blue color line here, from this blue color line, this is the total total hydrograph lah, okay, or the total observed hydrograph. If from here, if we remove the base flow, okay, in some situations, sometimes we want to really focus on the surface runoff. The surface runoff, that means we don't want to include the groundwater. We have to separate them. So from this data, from the total observed hydrograph data here, we have to know how to remove the base flow to get the red color dotted line here, which we call it as direct runoff hydrograph. Okay, and this is the main thing that we need to focus. Okay, this is the red. The red color dotted line is the item that you will see in most of the example lah. Okay, we call it as DRH. Okay. Next one. Okay, so this one is the summary lah. Okay. So we have rising line. Sorry. Okay, as I mentioned, so we have rising line. Rising line basically discharge increases from the beginning of the storm runoff, and then it caused by the surface runoff, interflow, and channel flow reaching the river. Okay, and then some of the factors that might cause the rising line, okay, rainfall intensity, catchment slope, soil infiltration capacity, and then the land use urbanization and the vegetation cover. Okay, all these are some of the factors that can affect the shape of the rising line. Next is the peak discharge. Okay, peak discharge or the crest segment. Okay, this is the maximum discharge of the hydrograph. Okay, that means the maximum if it's in the flood condition, we have the peak flood. Peak flood, so we want to know what is the highest water level or the highest discharge. Okay, and then yeah, occur after the peak rainfall due. Okay, don't care about the word lag time first. I haven't introduced that one. Okay. Falling line is the recession line. So falling line discharge decreases after the rainfall stop. Okay. So once water will store in the catchment, drain gradually to the river and control mainly by the groundwater flow and delay subsurface flow. Okay. So this is okay. So what you already learned last time. Okay. Last time we already learned rainfall hydrograph. So basically from this hydrograph, it can also tell you the shape of the hydrograph as well. So basically, most of the example here, we will see the hydrograph in the bell shape because we are only for our current syllabus, we are only focusing on one event, one peak event. We are not going to focus on multiple peak events. But in the real situation, hydrograph is not in this pattern, but it's a fluctuated pattern. Okay. Yeah, in the real situation, we will have fluctuated hydrograph, not bell shape. Okay. But this is only a single event. Single event, that means we have only one peak. Okay, from the maximum rainfall. We have the maximum rainfall here, so it will we will directly see the maximum. I mean the peak discharge. Okay. Next one, what I want to say is next is the time characteristic of hydrograph. Okay, here we have several important time parameters that in the hydrograph analysis. Okay, first we have the time of rise, and then time of peak, lag time, base time, and the time of concentration. Time of concentration, if I'm not mistaken, I think Dr. Jenny just before during the first chapter. Okay, I think she touched it, but if you can't remember, never mind, I just go through again. So for this five different time, okay, time of rise means the time taken from the start of runoff to the peak discharge. Okay, means that indicate how quickly the discharge rises. Okay, if you notice from this graph here, okay, the rising line here, okay, here this is the starting point. This is the starting point. Okay, excluding the base flow. As I say, we usually if you have given a hydrograph, we have to check whether this hydrograph is a direct runoff hydrograph or a total hydrograph. But if it's a total hydrograph, usually we have to exclude the base flow. So from here, what if I excluded the base flow here? The starting point should be somewhere around here. So here, from here until when it is rising until the peak discharge here, the time between these 2 points we call it as the time of rise. Okay, we use TR to represent. Okay, and then the next one we have the time to peak. Time to peak is the time taken from the centroid. Okay, from the centroid or the starting point of effective rainfall to the peak discharge. Okay, and this represents the overall response time of the basin. Okay, so time of peak also almost the same. Okay, it's also the same. I mean, from the starting point until the end. I mean, to the peak, we call it as the time to peak. Basically, it can be I mean, you will have almost similar value. Okay, between time of rise and time to peak. Basically, they are almost because they are showing the same point to the same starting. They have the same starting point and the same end point. So they might have the same value here, but the is different. One is the rising time, and the other one is the time to peak. Next one, you have lag time. Lag time is the time difference between peak rainfall and peak discharge. Okay, peak discharge and the peak rainfall. Okay, peak rainfall here. Okay, as I say, we have rainfall. From the rainfall, I mean from the pattern of the rainfall here, we will know the pattern of the hydrograph. But then the time here may not be the same as the peak discharge here. Because as I say, if this is the river, your precipitation fall on this point, and then it needs some time. Okay, it needs some time to flow until this point, right? This is the outlet tube. Okay, so the time here from a point the rainfall fall and then it flow out until the discharge here, there's a time for us to know the peak discharge. So in this case, the time here, we call it as lag time. Okay, which is the time difference between the peak rainfall and the peak discharge, because there's a delay here, delay between the rainfall and the runoff output. Next one, we have base time. Base time basically is the total time from the start of rainfall to the end of runoff. Yeah, start of rainfall. Okay, start of rainfall basically here, and then it will until the end of the runoff. So we call it as the base time. Okay. Next one, duration of runoff. Okay, this one is also the same thing as base time. Okay, time of concentration here. Time of concentration is basically the time of required for water to travel from the hydraulically, okay, most distant point in the watershed to the outlet. Okay, after TC of the entire watershed contribute runoff. Okay, in simple, what I can say is, wait, let me rub this. Last time, what you learned in the chapter 1, you know what is catchment already, right? And then, okay, in the catchment, we have river. Okay, every river, they got their own branch. I mean, branch of river. Okay, so the rainfall can be fall in every point, any point here. It can fall at any point. Then once we want to know the outlet here, all the water will flow into the outlet here, the time for starting for the water to travel through until the outlet point, we call it as the time of concentration. Okay, so these are some of the terms that you need to take note. Okay, time of rise, time of peak, base time, lag time, and the time of concentration. Next, we have factors affecting runoff hydrograph. Okay, so these are some of the factors that will affect the shape of the hydrograph. Okay, the shape, the size, the slope, the nature of the valley, the elevation, the drainage density. Okay, then our infiltration characteristic, like the land use and cover, soil type, lake, the type of the water. Okay, I mean the type of water storage. We have lake, swamp, or other type of storage. And then the channel characteristic will also affect our runoff hydrograph shapes, okay, like the cross-section, roughness, storage capacity. Then in terms of climatic factor, we have storm characteristic like the rainfall, intensity, duration, magnitude, and the movement of storm. Then initial loss, if I'm not mistaken, what we already learned in the evaporation chapter. Okay, evaporation chapter, and in the evapotranspiration as well. Okay, then if we are going to analyze the hydrograph in urban area and rural area, urban area is represent, okay, so this figure compare the two hydrograph in urban basin and the rural basin. The red color is the urban and the green color is the rural basin. So for urban basin, usually the lag time is very short because the water flow very fast. That's why we have what in urban area, usually we have flash flood. Flash flood, that means the water, I mean the flood suddenly happened. So because the lag time is really short. The peak, then we have high peak discharge, steeper rising line, here, and we have a steeper falling line, okay, because the peak discharge is very high, so the rising line and the falling line is also very steep. And then the time to peak, the base flow contribution duration of runoff is really short. Okay, because it's urbanized area and most of the pavement or the road condition are impervious. So that's why the water cannot infiltrate quickly. They cannot infiltrate into the ground or the soil. So what will happen? We will have flash flood easily lah. Okay, so that's why the peak discharge is much higher. But for rural basin, okay, the lag time is longer because the infiltration might be better. infiltration, the rural basin have a better infiltration rate compared to urban basin. So the area is permeable. So we have longer lag time, and then we have low peak discharge. Okay, gentle rising line and the falling line. Okay, and then we have longer time to peak, higher base flow contribution. Okay, higher base flow contribution. That means the water here, it can infiltrate into the ground and form groundwater easily. Okay, this is what we call the high base flow condition, and then we have longer duration of runoff. Okay, so next one we have direct runoff hydrograph. Okay, so this is the main term that I introduced just now. So direct runoff hydrograph represent the portion of the streamflow that is caused directly by the effective rainfall and exclude the base flow. Okay, so what is effective rainfall? Effective rainfall, or in some boat they call it as excess rainfall. Okay, we use ER or RE. Okay, any symbol will it's work. Okay, and both are same, and because some boat they have different representation. Some they use ER, some they use RE. Okay, so effective rainfall excess is basically the portion of total rainfall that remain after losses and contribute to direct runoff in the watershed. Means that the rainfall, okay, as if you if you see on this figure, so when the rainfall fall onto the ground, if the water didn't infiltrate into the ground, so it will become direct runoff. Direct or the surface runoff. So this one we call it as we also call it, so the rainwater here we call it as effective rainfall excess. Okay, so and here the direct runoff hydrograph. Okay, back to the graph slide here. So here we will have the direct runoff hydrograph, and this direct runoff hydrograph is only for that part of the total runoff, which is due to the direct precipitation excess. Okay, so from the excess rainfall, we will form direct runoff hydrograph. And then this graph exclude the groundwater. And then this part is also important for us to estimate the flood, design the hydraulic structure, and then we will later we have one subtopic which is on the unit hydrograph, and then watershed response analysis. Okay, so how to obtain this direct runoff hydrograph? Basically, we have another section here, subtopic here. We call it as the base flow separation. So base flow separation is the base flow separation is the process, earlier process that we need to do before we analyze any hydrograph. Okay, so base flow, as we say, base flow is the portion of streamflow that is sustained by groundwater and is present even in the absence of rainfall. So it forms the lower boundary of the total hydrograph. Okay, so once we got the streamflow data, okay, no matter where we get the streamflow data, usually we get streamflow data from the DID or the GPS. Okay, the data there is, we don't know whether there's a base flow or not. So usually once we got the data, and if we want to know the flood, if we want to analyze the flood, okay, the history flood. So what we're going to do, once we got the data, we have to exclude the base flow. Okay, because their data usually is contain the base flow. So once we got the data here, we have three ways of separating the base flow. The first one is straight line method. Second one is the fixed base method. And third one is we call it as the curvilinear recession curve method. Okay, so these three methods, any method will also, we can try to estimate the base flow here. As I say, everything is estimate here. So any method will also able to estimate the base flow. After that, we will deduct it. The whole data, we will deduct the base flow, and then you will get the direct runoff hydrograph. Okay, so here I have two examples. Okay, basically these are from the YouTube. Okay, so I want all of you later after my lecture today. Okay, this is my last slide for today already, basically. So after my lecture now, you will have to watch this YouTube, and then you follow their example. And then you have to submit submit in the ITL, but I forgotten what I said already. I probably tonight. You have to submit by tonight. Okay. So straight line method and fixed base method. So these two you have to use graph paper as well. So please try to follow the example and then you submit by today. Okay, so today this one will be considered today attendance as well. Okay, we have two types of attendance today. Okay, first is the one Google form that I give, and the other one is the submission of this two. Okay, two example. Okay, so that's all for today's lecture. So I mean for part one basically. Okay, any question?
Sorry, doctor, but for the attendance form you sent, I can't see my name.
Okay, wait, let me share again. I think someone pinned already, right? I can see.
Yeah, doctor, it is the same, but the names, don't know, maybe there's a mistake.
Oh, okay. The name, okay, yeah, because I used my other class. Wait a minute. Yeah. Okay, I said it already. Okay. Who is talking with Dr. Fauzi? Okay, okay, the Google form I already reset. Can you check it? Okay. So any question? Okay, if
mungkin dia mau bayaran, dia mau temu di per hari. So jam 4:30 dong packing saya itu. Sekarang jam 3.
Zulaidin, can you off your mic?
Very sorry, doctor.
Okay. So again, please do the two example as I mentioned, and then later you just submit in the ITEL. Okay, then for next Monday class, okay, please get ready all your graph. I think graph paper also needed. If you are using Excel, then you don't need graph paper. But if you think you want to use Excel graph paper, then you just bring as well, okay. For the next part two later, I can show you first. Okay, basically we have three subtopics here, but then a lot of example under this part two. Okay, we have, I think if I'm not mistaken, there are 1, 2, okay, 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5. We have 8 example. Okay. 8 example. So next Monday I have to go through all this, probably part of the example, and then Wednesday we finish it. Okay. 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 So if no questions, so we shall leave this class. Okay. So we are dismissed. Okay. Okay.
Thank you, doctor.